So hello student, welcome back, and today we are going to continue our series on question 6 electricity. Okay, diagram flow show an oscillator of cathode ray is used to differentiate the direct current and alternating current. Because I think last video I already showed that how you want to know is to see this one. This one. So alternating current, it will go up and down, something like the dynamo. Direct current, you will usually get a straight line. Usually from this one also is a very good graph. This also is a good graph. This also is a good graph. It's a you can get this one from a cathode ray. We call this as a cathode ray. Also used in the hospital. But it's also used in hospital the cathode ray. I think the hospital one is to detect sound. Detect sound or electric is still the same So in the hospital you always see this thing tit means the person heart is beating. As long as it beat, it will go up and down when the person is breathing. And if the person die already, it will be a straight line. We know that the person died already. So this also we use in to know the current, that we want to know whether it is direct current or alternating current. And also we are using this in the hospital to ensure that the person is still living and breathing. Of course, this is very good for the doctor. This one can adjust one. You can adjust the how big the wave, how small, so you can see how fast the thing you want to go. So you can see, because in maybe I don't know I'm not a doctor. Maybe the doctor do operation, he want to see how fast or how slow the person heart. If the person heart beat very fast, also something is wrong. If beat very slow, also means it is something or wrong. Or beat how strong, the beat is very strong or the beat is not strong, very soft. So the doctor, I don't know maybe you do operation that time, you want to see whether there is something wrong or not. But a normal person should have a normal heartbeat unless you go exercise, the heartbeat will go faster a bit. And if you are sleeping or in a relaxed position, the heartbeat will go slower. So this is a common thing. Sketch a wave producing alternating current. So sketch a wave, you know how to sketch a wave or not? So of course, if you don't know, you can always Google alternating and direct current, and maybe I just put a cathode ray, and you should get the answer. So the answer will be something like this something like this for the alternating current. Now you can draw like this, you can draw like this, you can draw like this, as long as go up and down either you want to just do 1 line, 2 line, or 3 line, up to you as long it go up and down you the reason it go many or slow, it depends on the speed that you want to set. If you set the speed very slow, then it will go many times. If you set the speed very fast, it will something like that. So let's draw this. Many line you can try so I just choose which one you like. I choose this one whatever anything you choose just make sure you draw the line you like. Just the most important thing is up and down. So I just draw up and down up, down, up. Draw nicely a bit Okay. So this is the reason I draw this is alternating current. If it is DC, direct current, DC, then the line will be just a straight line. Okay, if DC. Why we use alternating current in our home instead of direct current? This one also we already discussed in the previous video, because because if you do science quite a lot, they are always asking the same question only. So we can say that Why do we use alternator instead of our direct current? Many answer. So one of it is, let me take my pen. One of it, I just put here lah, AC and DC. And we know our home is using AC because first AC is safer. DC is safe. AC is safer. This one is more dangerous. I just do a point form so that you can do your own. One more thing we can say is the alternating current save electric. This one more use more electric. It will waste more electric because you need to explain. Because wait, let me say this. There is an energy loss. Energy loss is lesser compared to here. Energy loss is more. Energy loss while transmitting is more. Energy loss is more. Okay. Why is it AC save more energy? This one hopefully it won't but if you hopefully it won't come out in exam because you need to explain why it save more energy. Before the energy go to your home, there is a network grid. There is something like this one, the pylon, the electric like this, it will go to your house. I don't know why they put this in chapter 3 I always don't have enough time to teach this chapter, because it's a very huge chapter. Okay, there's always this thing that energy that go to your house, and energy will cause energy loss because due to the resistance of the wire. Because the wire very short, then you don't care because the wire is very short, like you just take a battery and charge the light, it doesn't really matter anyway. But if this electric, it go to your house, let's say it need 20 kilometer, then it really matter because you need to put a very very long wire. If I use a charger cable to charge my phone, so near, I got no problem. But if I take the wire, I put very very long until the whole house, and then I want to charge my phone, then my phone cannot charge also, because I put in USB wire, I connect many, maybe I put 20 meter. Usually the phone charger wire is 1 meter, but I put 20 meter. I buy a very long extension of USB cable, I make it 20 meter, and it doesn't work anymore. It maybe work, but you charge very slow. Maybe if you want to try change to 50 meter cable to charge your phone, it doesn't work anymore. But why this doesn't work? Because of energy loss. Energy loss due to resistance. The energy will lost because your wire very long. Even you give more electric also, you give more and more, but there is no electric because the energy, when it go through the wire, the energy is lost. Maybe due to law of conservation energy, the electric is lost, become heat. So eventually the wire become hot then the electric will just disappear. But you say where got the wire be hot? Of course you cannot see the wire is hot because the wire is so long and you don't even can feel it, okay? Because the wire is too long already. It got hot little bit only, okay? So you cannot feel it anymore. Yeah, so every wire that you use, always there is a resistance. Resistance will cause loss of energy. And when we are talking about this wire, which is very 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 long, this wire which is very very long, let's say 10 or 20 kilometers before it reach your home, it will lose a lot of energy due to the heat that is leave from the wire. So in order to reduce this heat energy, they need to use transformer to hijack up the voltage, go up the voltage. Oh no, I don't know whether you understand or not. Then they need to lower down the ampere, okay? Go up the voltage until a few thousand watt, and then the ampere is I don't know lah, maybe 240 ampere or what. They will reduce the ampere, increase the voltage, and then before it go to your house only, they reduce the voltage and increase the ampere. Okay, what am I talking about? You don't understand, never mind lah, but it is something like this lah. They just need to change the electric little bit in order to avoid energy loss, okay, in the pylon, okay, the electric pylon to your house. Just then they need to change the electric a bit. And if they use AC, they cannot change the electric, because DC you cannot jack up the voltage and reduce the ampere, cannot. Only you use AC, you can increase the voltage and reduce the ampere. So eventually if you use AC, there's a lesser energy loss, and depend on how many mark lah. Actually the answer got explain, so you need to explain because maybe you can say the voltage for the voltage that is being transmitted to the house can be increased. This will reduce the energy loss. Don't understand also, never mind lah, because I don't know, they ask this, then it's very difficult to explain. For your electric, there is always voltage and ampere. If you notice, you buy power bank or you buy whatever phone, they always put the output. If you see a power bank properly, they will put something like output. Input is to charge in output is I don't know lah what power bank. Usually it's 5 watt 2 ampere. If you see your power bank, that is 5 watt 2 ampere usually lah. I think all power bank also got this thing, 5 watt 2 ampere. Electric always got watt and ampere. If I'm going to take a plug out from my house, there is a voltage and ampere. Not only one, we say one, let's take some example. Let's say the water pipe, the pipe water the pipe water only got 1 meter only, because how many water you use? 1 means 1, 2 means 2, 3 means 3, 4 means 4, 5 means 5, and so on. Okay, so this is the water pipe. Or maybe your car kilometer, how long your car go. Your car go very far, so 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer, and so on. So easy to count, because it's just 1, 2, 3, 4, 5, 6 is like a scale, ascending order. But for electric is more special, because there are 2 calculations. You need to time these 2. That is a voltage and ampere. Okay, voltage is how much energy you want to carry. You want to carry more energy, so this is the guy. Let's say this is the guy that carry the voltage to the house. Okay, to the house. So the 5 watt is the thing that he carry. Ampere is how fast he want to go. How fast. So that's why the electric, we always got 2 calculations. You can carry little, 1 watt, but if you go very fast, it's still the same thing. Or you can carry 1 million watt, but you walk very slow. So the energy also is very little. So when we talk about energy, we always talk about voltage and ampere. That's why you see in your power bank there is a voltage and ampere. Voltage means how much energy you want to carry. Current means how fast you want to go to there. So if the current is faster, more current means more fast. Lower current means slower. So that is more difficult in the electrical. Not like pipe or kilometer, because you just see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But for electric, there is voltage and ampere. Okay, let's read. Yeah, okay. So I don't know whether you guys want to go for science stream or art stream. Science stream is more difficult. Yes lah. If you want to say about marks, I think science stream is more difficult to get mark. But if you want to talk about the science, that is the problem in Malaysia. I don't want to say Malaysia. In some country, actually both is hard. It's the same thing. You go to business stream or art stream, or you go to science, both is the same one actually, because um just because they make the question easier, that's why it looks easier. But actually, maybe sometimes art stream is more difficult, because art stream sometimes is more to do business, to do account. You study account and you want to do economy and business, and actually to do business is more difficult than becoming a doctor, I think lah. Because when you become a science teacher or doctor, you just read from book, and everything is the same. But when you do account, business, you need to think, you need to earn money, you think, and you need to deal with human. And it's very difficult to deal with human, because human always change one. They like, they don't like, they like this government, they don't like government, they change. But for science, 1 plus 1 is always equals to 2, and like mathematics. So I think you should choose something that you like is better, not to choose something that you think it is easy, or something you choose that it is difficult, but you should choose something that you like, because I think you'll be happier lah. If you like account, then you go to account, and if you like economy also very fun one. It's not like what I also like economy. I also got do something, so I also like economy, I also like science. Depend on you lah. Choose something that you like. Then if you like economy, then go to economy. It's very fun. It is something that I always struggle to understand, where the money go, why the economy go down, and who knows, one day you can become rich. Usually you want to do business, you just go to art stream, should be better. But if you're a science stream also, you can go upstream. Up to you. Okay, read the situation below carefully, then answer the question. An island has a large number of wind turbine and coal-fired power station. The island needed to use the electric generated by the coal power station at certain time. Why? You understand the question or not? He got wind and also coal. Sometimes he need to use coal. Why?
Turbines will not use for certain times because there's not a full day of the day, there's no wind in the island. So when there's no wind, they use coal-fired power station.
Yes, very good. Okay, so I think you have. So of course you use wind and coal. The keyword is if, of course, not every day you got wind. So if there's no wind, then you need to use coal. If not, later the people don't have electric already lah. Suddenly 2-3 days no wind means no electric, and that is a problem. I think many country or certain place, usually many country or many place also they got coal, just in case emergency. You also can use solar at Japan or what, but sometimes no sunlight, then you need to temporarily use something, so you can use coal. So just make it into a word. So maybe we can say there will be the absence of wind to generate electric. Anything lah, just use your own answer lah. In the situation of absence of wind, coal can be used to generate electric. Can lah. You use your own word lah. The keyword is no wind, then you find something to use lah. But now very high tech already lah. Now no wind got battery. I heard they say Tesla car is going to be sold in Malaysia soon, and the battery can be used up to 400 kilometer. Means from here you charge fully in your house, you can use from KL to Penang using a Tesla car, and the price also is not expensive, like 300,000-400,000. I mean, I say not expensive not because I rich lah, because I see in the road also got people drive Porsche, people got drive Mercedes and BMW. Sometimes BMW also 500,000, and 500,000 is more expensive than the Tesla car they are going to sell on in Malaysia. B. Hydroelectric power is found in the water when it flows from a high position. A dam is built at a high position to hold the water. Okay, so of course this is the dam lah. This is the dam. Just make the water high a bit. and this is the generator, so the water can pass on and turn the turbine. So you can see this is the water coming out at the bottom. I just put a lot of the turbine to so that it can move and generate electric. Where a dam should be built in order to make use of the hydroelectric power, and what are the back effect on the environment when we use hydroelectric power to generate electric. So this question got two questions, correct or not? Where a dam should be built. The first question, where it should be built. Well, when we read question, we read properly. The second question is, what are the bad effect on the environment? So let us answer the first question, where the dam should be built. So of course the answer is river. Maybe we can say at the river mouth, okay? At the river mouth, okay, where the water is coming out in a certain location. So obviously it will built in a river lah, huh? And what are the effect on the environment? So of course if you build the dam, people sometimes last time I was a student, I thought that the dam is always a good thing because it's a renewable energy and you can use it and use it. But actually there is also a downfall, and let's see, I can Google it and see or not. It will destroy many places. Let's see. Here cannot see. There is no real picture to see before and after a dam. I think the best picture is only this one I got. So this is the residual harbor natural reach. Okay, but anyway, when you build hydroelectric, a lot of the land will be destroyed. The land, maybe last time, if you see this picture, the picture is only like a small river only. Here is just a tiny little river because it's supposed to be a river. Then after that you build the dam, you block the water. So when you block the water will rise up. So all the place here will be destroyed. If your house is here, it will be destroyed. If your the monkey stay at here, the monkey need to go to somewhere else. If there is a monkey, elephant stay at here also, you need to go to other place. So eventually it will destroy a lot of the land, because you can see from here it's just a small river, but once you block it, it become a very big river, and we are talking about here the water will go up to here. You cannot see lah, but it will go to a very big place, so it will destroy many area. So we can say that, how to say this, wildlife, it will, maybe I can say that it will destroy the habitat of animal. For example, many land will be destroyed if you build the hydroelectric. That's why sometimes also if can also I choose solar energy rather than hydroelectric, because first it destroy many place, second also it could be dangerous, correct or not, due to flood, and sometimes this thing will break and it always cause flood. Like the banjir also, the banjir happened in Malaysia because also, the half is better lah. They actually block the water, but because the water go too up already, they need to open. I forget what place already, the banjir that recently happened in Malaysia, they need to open. So when they open, the water come out very fast and they need to flood the village. But if they don't open also it's even worse. If you don't open, the water will go up and this thing will break 会爆 so if this thing break then it is even more dangerous. So and eventually they open even though it destroy people and it cause the people to die. I think this one I remember it at Johor. It rained a few days non-stop. So because it rise up to the emergency level, they open the water, open quite a lot lah, then it flood the people in the Johor, and then the Johor people, a few people die due to the flood. So maybe mm, not all things also can cause accident lah, hydroelectric, nuclear energy, solar energy maybe no accident lah, Okay, transformers. What is a transformers? I can say again.
A transformer is a device for changing the voltage of an alternating current.
Yes. So a transformer only can work either it can step up the voltage or step down the voltage. Either you want to make the voltage go higher or make the voltage go lower, and it only can be used for alternating current. That is why previously we already studied why we want to use alternating current to put in your house, because we can easily change it. We can change the voltage go up or the voltage go down in order to transmit the energy voltage. So last time I always wonder, like if I put transformers, the electric will go up. So I put many transformers, then I got many voltage electric, then yes, I got very cheap electric, I got very free electric. But it doesn't work that way. It doesn't work that way because when you step up the voltage, the ampere will reduce. I already teach, right, the difference between if you step down the voltage, the ampere will increase. So there is no free energy in this world. Even though you use many transformers you put in front of your house in order to increase the voltage of your house, you thought you get a free aircon, but it's not a free aircon. It's just like you are increasing the voltage, at the same time you are reducing the current. Means the last time I already draw, the person carry the bag is the energy, is the voltage, and how fast the person want to go is the current. So if you increase the bag very big, he will walk very slow. He will walk very slow to your house, and it is still the same thing. You still need to pay the TNB. So it doesn't really matter whether you want to increase or decrease it. But for TNB, they only want to increase a lot at here. Okay, the wire that's going to your house. They want to step up the voltage very high and lower down the ampere, so the person walk very slow. But by doing this, it will reduce the resistance, it will reduce the resistance, it will reduce the energy loss a lot. So that's why the TNB want to do something like this. Okay, where was I already? So this is the example of transformer, and how can we label these transformers?
C is secondary coil.
Second.
And A is, I think it's laminated iron core.
Very good. Laminated iron core. So this is the how you want to basic transformers lah, primary coil and secondary coil. So let's say here is 10 watt lah, let's say here is 10 watt. So you count the line, 1 line, 2 line, 3 line, 4 line. I cannot count. 1 line, 2 line, 3 line, 4, 5, 6, 7. I just assume here got 8 line lah. Just assume here got 8 line. Here got 4 lines. So if 10 watt, it go to here, it will become 4 watt. 5 watt. Because here divided by half ma. 8 divided by 2 you get 4. So 10 divided by 2 you get 5 watt. Okay, because you calculate it according to the ratio of the turning. Turning of the thing. Question number 9. Again, this is I think it's a transformers. Diagram 5 show about of 12 watt. That's why you say again it got give the this is the voltage watt. Okay, so how to get the watt? What is the formula for watt? W-A-T-T. So this is 48 watt and the bulb is 12 watt. Not same watt. 48 watt and it's not same. So what is the power? Power equals to this formula you need to remember. Power equals to current. You want to write this down if you don't know this. Power equals to current times voltage. Okay, power equals to current times voltage. So I already say that we already mentioned in the previous video. Let's say we talk about power bank. Power bank, you see there is a 5 watt. Power bank is 5 watt and 2 ampere. So what is the watt? Yes, the answer is 10. Power equals to current times voltage. So power equals to voltage times current. You get 10. What's the unit? What's the unit for 10? 10? W. Very good. W. So this is the example you need to know. So you can see nowadays got Google. So I borrow Google for a while. So you can see here is another example. Power equals to current times voltage. Let's say the current is 6 ampere and the voltage is 18 watt. 6 times 18 you get 108 watt. So this is how you calculate the power for the phone. Let's maybe choose a phone for comparison. Let's say I choose this phone Nova 8SE. Why? Let's be more practical a bit so that we can use in our daily life. So let's see this phone Huawei need how much electric to charge. Wow, so this battery very good You can see that the charging is 66 watt. 66 watt is the charger. So next time when you want to buy power bank, you need to buy a 66 watt power bank or the charger. So maybe you can charger for 66 watt. So phone charger. So this is the phone charger for 66 watt. You can see that it is more expensive. You can buy also very cheap one, but you need to buy a 66 watt. Because if you want to use the old power bank, like I got the old power bank, the old power bank is usually just 5 times 2, so it's 10 watt. So you use the power bank to charge this phone, no use one. You want to charge this phone, you call it Huawei Nova 8SE 4G. You can charge the phone but very slow because it can go up to, here got say 66 watt. 66 watt. Fast charge 66. It depends on your phone. My phone is 15 watt, 15 W. This so of course more is better more means it is faster. But this one more no use if you use back your old charger. You need to get a good charger. So you need to be careful. Some people don't know. So what they do is they just use any charger. So when you use any charger, let's say the charger is 66 watt, but you want to charge your old phone, and sometimes the phone spoil because you don't the watt is not correct. So you always buy the charger or power bank according to your phone needs. so that you don't use too much money or you don't use too less. Sometimes the charger got many ones. Some is very cheap, some is very expensive. But which one you should buy? You look at this one, you go to this website, then you find your phone, you should find your phone, this one, the watt. After you find, then you know which power bank you should buy and which charger you should buy. That is more practical. Yep. So this is how you know. So now you know science, then you know it's good. If not, you simply buy no use one. I give you buy iPhone, but pasar malam charger can charge lah, very long lah. Okay, so that is how we calculate. Okay, the function of transformers, I think just now the student already mentioned, which is the transformers can increase or decrease the potential energy or voltage by using alternating current. Okay, so this one is the student just now already mentioned. You can find in your book or Google, so I don't need to write down. What is the type of these transformers? Okay, very good. So this is a step down transformer. Step down. The reason we see here got many, here is lesser, so we know that it is a step down transformer. Okay, let me just erase this. I feel like very messy already, so that I don't confuse myself. Okay, if the number of the P square is 2000, what is the term for RS? So this is a mathematic calculation. So you need to write down first. Here is 2000 turn, and here is 240 watt. Here is 12 watt. So what is the turn for this one? So the answer is 100. Okay, so you can use just 2000, the turn, number of turn divided by the voltage, equals to the number of turn you don't know, you just put X equals to 12 watt. So X equals to mathematics 2000 divided by 240 times 12, you get 100. Okay, and I think it's the same even if you put it upside down. Let's say if you put down here 2000, let's say like you put here down 2000, up is 240, equals to let's say the number of turn you put here X, and up you put is 12 watt. So what is X? So you will still get back the same answer If you want to put everything up, the number of turn up, the voltage down, then you just do the same. Or you want to put the voltage up, the number of turn down, it is still the same. Up to you which one you want to use. So of course this is just 1 mark, but you remember to write the formula So maybe you can just create your formula number of turn for primary divided by voltage for primary equals to number of turn for secondary divided by voltage for output. I just put my handwriting like this I hope you understand, but I just want to say the formula for transformers is the best if you write down the formula. Wait, I just get you cannot see my handwriting so I just Google better formula for transformer. Okay, so where's the easy one the easy one will be this one VP. V is the volt volt primary divided by volt secondary equals to number of turn for primary divided by number of turn. You can even write this formula if you want, up to you whichever you like. I write wording I scared you guys confused, that's why I write wording. Okay, let's finish this 1. Now it's already 10 o'clock. Okay, let's do this last question. Table 1 show the reading transformer with a different number of turns in the coil in the secondary coil. State the manipulated variable in this experiment. Yes, number of turns. So when we look at this picture, it obviously, usually, the first one will be the manipulated variable. You still remember? The second one will be the responding variable. Usually, it's always like that one. In your hypothesis, there's always two tables, or x and y. Usually, x will be the manipulated variable, y will be the responding variable in the table. I mean, in science, it's always the common. So if they put up, it usually is like this. If the table are x and y, x is the manipulated, y is the responding. If they put a table like this, usually x is the manipulated, y is the responding variable. And if they give you a graph, x and y, x is the manipulated variable, y is the responding variable. Maybe almost when you go to university also it's like that. I think it's something like a standard lah. So always remember, the first one will be the usually lah. But in order to know, the best is to know the hypothesis of the experiment. Then you know if you read the hypothesis. But here they didn't give the hypothesis. Show the reading of transformer. So it didn't say anything. But we agak-agak lah. It didn't say anything. But we agak-agak we know that manipulated variable will be the number of turns. You write here lah. Number of turns. And responding variable will be the voltage. State the relationship of the number of turns in the coil and the what. So this is the relationship. I think it's more towards like hypothesis already. So they just give you bottom to you find the hypothesis of this experiment, the relationship. So remember a relationship or hypothesis usually is what become more and then that one become more, or what become less and that thing will become less. So this is very important. When you look at this picture, you should able to know what you want to do. If you don't understand you many questions you cannot do. So let's understand this question first. Okay, the manipulated variable is number of turns. The responding variable is the voltage. So I thank you Wei Chen for telling me to look at the table. Sometimes I also start to forget. I start want to tell the answer only. Okay, so we can see that manipulated variable number of turns. If the number of turns in secondary coil increase, the output voltage increase. You see or not? That is the relationship. What is the relationship you can see from the table? The relationship that you can see from the table is, if the secondary coil increase, output voltage increase. Let me check the answer later. I scared I teach wrong. The higher number of turns in the secondary coil, the greater the output. Same lah. So the increase, if the number of turns in secondary coil increase, the number of secondary coil increase, and then we look at here, the output voltage increase. The output voltage increase. So that is the relationship. And why I know this relationship? Because one thing I can look at this table also, I can know the constant variable. The constant variable means the thing that you cannot change in order to make this experiment fair. Very pain my neck. Okay, so we can see the constant variable is this one. You remember, right? Constant variable means you cannot change in order to make the experiment fair, testable, free, valid, reliable. So that must be have a constant variable. So this one you cannot change. So let's say the question asks what is the constant experiment variable? The constant variable for this experiment will be the number of primary coil and the number of input voltage. How you know? Because you can see no change, no change. If you want to change this one, I like to put here 10, 9, 8, 7, 3, 4. Then do what experiment? There's nothing to do for the experiment. That experiment is not valid, it's not reliable. Because there is a problem with the methodology and the design of the experiment. Because the way the student do the experiment is wrong already. Because there is no constant variable to ensure that the hypothesis is measured. This is means when you start to do experiment, your title, your first thing you want to test is this one. If secondary increase, then voltage in output increase. So you need to put the constant variable and you test it. You say the methodology lah, take the wire, do step 1, put in the secondary with secondary coil with 10, repeat the experiment with 30, 40 and 50, repeat step 1. So you get the result of the experiment is tabulated, is collected. So that is how you do an experiment. Get what I mean or not? But so basically I want to say is when you look, you should able to understand. If you don't understand this one means many things you cannot do. First thing you want to do is know the variable. I use first thing you want to do when you look at the let's say this picture, you know the variable. I got no better color, man, just black color. Find the variable, okay? After you find the variable, you should get the hypothesis. If number of turn increase, number of voltage increase, okay? So you get, because you got variable, sure you can get the hypothesis. Hypothesis is the relationship. After that, from here also, one more thing you can find out is the constant variable. Something that you cannot change in this experiment in order to make sure that the design of the experiment is valid and reliable. Okay, so I will teach until here. Is there any question? Okay, no, then I will teach until here and I see you next time. Bye bye.
Thank you, teacher.
Thank
Thank you,
you.
teacher.
Bye bye.